picture of the fixture. I should probably record. Okay. So this is just finding the foot candle. The next step, which is very important for you, since you guys are going to be lighting designers, the next step is how, Brad, am I going to be putting all these fixtures inside my room? How am I going to lay out these fixtures inside my room? Let me tell you how I would do it. And then you do it your own way, like Ryman would say. 39 fixtures. Any question first about how to find the fixtures? Straightforward, right? Holly, you plug in the numbers, you find how many fixtures you want. Now, challenge number one is how are you going to place these fixtures in the room, right? How are you going to place your fixtures in the room after you find how many fixtures you need? This is you guys are going to be doing it with me. You're going to start with a room in the software. Chad, where am I going to start? Here's the software, here's a room. How am I going to start placing my fixtures? I know I have to have 6 fixtures. How am I going to start putting these fixtures physically, mechanically, so I can give it to the electrician, and the electrician will move. They're going to be moving, say, 4 feet from here, and 6 feet, 4, 6, and they put the first fixture center is right here, and they continue. Okay, so this is, we're going to talk about distributing the fixtures in a room. Any question about calculating the foot candle, guys, before I move there? I can't emphasize the next step is very important because that's what you guys are going to be doing in visual. Trying to find, first, how many fixtures, second, how do you place them? Third, we're going to show you how visual is really much easier than that. There's a trick where the software can do that too. All this calculation can be done, even the layout can be done by the software. But okay, next step, Mr. Verbab, we're going to take these 39 fixtures and place them with dimension in this area. Here's what I would do, guys, personally. And there's a few tricky stuff that you're going to do. Here's my area. I'm just going to emphasize what my area was. It 30 by 20, right? 30 by 20. And I know the number. Is it 30 by 20?
30 by 20.
50 by 60.
Yes.
That one, is that the example? I'm sorry. The example of 60?
That was yesterday.
How did we?
The first one was 30 by 20.
What was this
the
one
next
say?
one was-
This number was, the dimension for this one, what was?
50 by
50, thank you. 50 by 60. 60 feet by 50.
Around all the way back on.
60 by 50.
Holy cow, that could have killed me if I didn't know that.
Okay. All right. Sorry for that. So this is a 60 by 50. Well, there was 2 examples, and I lost my recording. I'm sorry, guys, yesterday. So 39. I have 39 fixtures. 39, guys, is a what I would do, since this is, if it's a square, take the square root of the number. Had this been a square, just take the square root of 39. Obviously, root of 39 is not an actual number. What I would do to find how many rows, I'm going to find how many rows and how many columns I need. What I would do in a case like this, guys, instead of 39, I'm going to put an extra fixture, make them 40, just to place them evenly, okay? And that's a decision that you do. I want to single-handedly, Chad, make these fixtures. I'm going to tell you why. I'm going to make them 40 fixtures, okay? That's calculation. And then I'll take the 40 fixtures, here's my 40, and I ask myself, what are the 2 largest numbers that I can multiply with each other to get me a 40? I can get 40 by 4 times 10. 20 times 2 means 20 rows, 2 rows and 20 columns. What else? You want these 2 numbers, guys, that you multiply by each other to be as close to each other as possible. So I have 10 by 4. What else can give me 40? 8, 5. So my options, again, and that's really my method. My option is 8, 5, or what's the other one? We said 10, 4, or 20, 22. What are the other options that can give you 40? 40. 2 numbers you multiply by each other to get you 40. Okay. So 8 times 5, 10 times 4, 20 times 2. Then I pick, guys, I pick the option where the 2 numbers are closest to each other. So obviously the two numbers are closest to each other. It's 8 by 5. There's a closer than 10 by 4, right? In terms of how far is 5 from 8. So I would choose the number, and please write yourself a note. I picked the 8 by 5 because that will give me almost close number of rows and columns. I'm looking for number of rows and columns, guys. Okay, so 8 by 5. Why 8 by 5? Because 8 is closer to 5 than 10 to 4. That's why I picked it. Would it be wrong if you pick 10 to 4 by 4? No problem. But your distribution of light, guys, will be better if the number of columns and the number of rows are equal. That's ideally. But obviously, you're not going to achieve that one in a situation like this. So, okay, any question why I came up with 8 by 5, not 20 by 2? For example, 20 by 2 will be a bad design. So you have 2 rows and 20 columns in between. It works, but the light distribution is not the best. The light distribution, guys, is the best if you end up with number of columns and number of rows, the same number. Okay? Obviously, I can't in this situation, so I have to go by 8 by 5. Where do you think the 8 is going to be the longest? 8 is the number of the 8 is going to be the longest distance. So I'm going to go with 8 columns. So here's 1. I want to divide this area to 8 areas. Here's 1, 2, 3, 4, 5, 6, 7, 8. Anybody disagree why I put the 8 columns instead the 5 columns? You put the largest number where the largest distance is, right? So the 8 went at the 60 because 60 is more than 50. And what do you think so these are my columns. The next is going to be my rows. What do you think my rows are going to be then? I have 4 rows. So here's my 4 rows. 1.
We have 5.
Yeah, 5. Thank you. 1, 2, 3, and here's my 4 and 5. Right? There's 1, 2, 3, 4, 5 areas. Any question about this, guys? So you started by dividing them 8 by 5. It doesn't matter, guys. The largest number always goes with the largest distance. The largest number always goes with the largest distance. Does that make sense? So you can put the 5 here, but it's not a good idea. The good idea is always the largest number goes with the largest distance. Okay, and then after you divide it, we're going to end up with how many? 40? Is that 40, guys? 1, 2, 3, 4, 5, 6, 7, 8 times 1, 2, 3. So then you go to the center of every rectangle that you did, and you put your fixture right at the center. Here's my center. So I come over here. Here's the center of that. Oops, I'm not. Yeah. But you guys with me, here's my center of this rectangle. There you go. And you put the fixture right at the center of this rectangle. Okay? And then you do the same thing for all the other fixtures. Right here, here, and here, all the way. And you got the message, huh?
Seems like a lot of lights here.
So, remember how many foot candle we need? It was 80-foot candle. That's a lot of foot candle. So here's all your fixture right in the center of the square. Okay, let me just finish this one. Almost done. Okay. Right in the center. That's how I distribute. If you do it this way, guys, you're going to get 2 things. You're going to get your average foot candle, and you're going to get the best distribution of light in the room. The best What's the best distribution of light in the room, Spencer? Meaning this area is not going to be too lit compared to this area. The different, what they call it, maximum to minimum value. The maximum to minimum value of foot candle, you want this to be minimized. You want the brightest spot in your room and the darkest spot in your room to be as close to each other as possible. You know, you don't want one to be like 100-foot candle, the brightest spot, and the darkest spot to be 20. That's way too. The max to minimum is too high. That's why distributing this way that will give you the best average and the best distribution, meaning the maximum foot candle to the minimum foot candle will be very close to each other, meaning the ratio is going to be small.
And this one was 80, right?
This one was, what do you mean, 80 foot candle, average.
That's the average.
That's the average, okay? The last thing, guys, is you need to find the distance so you can start laying out these fixtures. And you're going to ask me, Spencer, you're going to say, oh, Chad, what if this grid here is different than what you did? No problem. If the grid's slightly different than what I did, you just adjust yourself to fit the grid. But you know how your pattern should be, you know? Okay, so you come over here, and we need to find, guys, the distance from, so these are 2x4. I don't know if I mentioned, we're using a 2x4. These are 2 feet by 4 feet, the fixtures. So from here to here, what's the distance from here to here? What's the distance from here to here? You have 60 divided by how many? By 1, 2, 3, 4, 5, 6, 7, 8. So 7. So this distance, I call this is the x distance. So x equal 60 divided by,
It's 7.5 feet.
by 1 by 8 equal 7.5 feet. So this distance, guys, is 7.5 feet. Everybody knows why I came up with 7.5 feet? The distance. You divided the length by the number of columns that you have. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's find the y. Let's go find the y. I want to go find the y. Here's my y. What do you guys think y should be? Y equal, you're going to divide the 50 by what? By 1, 2, 3, 4, 5. 5 equal 10 feet. Everybody knows where the 7.5 of the thing came to be? So y, so I have an area of 10 by 7.5. 10 by 7.5. Any question about that? Here's my y, here's my x, and right in the center of the y and the x, I need to get my fixture. I need to get my fixture right in the center of the. So my area is going to be 7.5 by 10, and right in the center of that square or rectangle, 7.5 by 10, I'm going to put my fixture. I'm going to put my fixture. Okay? I'm going to take this square, guys, and just do the calculation for the first fixture, and then you calculate the rest of it for the first fixture. Any question about how we came up with x, y, the first corner, so we can lay out my fixtures? I'm going to lay out my fixtures. Any question about that? So x is 7.5. You divide it by the number of, in this case, by the number of columns, and y for the number of rows. Okay, so I'm going to take this little square here, and here's my fixture right inside it. This was, we said this is 10 from here to here, and this was how much? This is 7.5, 7.5. Right at the center, what do you think from here to the center of this one? What do you think from here to the center of the fixture? To the center of the fixture, half of 7.5. What's half of 7.5? 3.25. So I go 3.25, 3.25, and I need the x now. This is the x. I need the y. What do you guys think the y is? 10 divided by 2 is 5. Perfect. So you go 3.25 and a 5. So you measure. We're going to be measuring 3.25 from here, a 5 from here, and that will be the center of my fixture. That will be the center of my fixture. That will be the center of my fixture. And then after that, guys, you start adding the distances and going forward, horizontal and vertical. Any question?
You would just add the distance. After you got the center, you would just add.
Yep.
Just add. distance
between them.
between them.
Yep,
It's not.
I know, but I want everybody to know it though, right? Everybody knows that. So
Isn't it
It's 3 3/4.
3 3/4?
3 3/4 instead of 3.5. Okay, 3 and 75. So the distance here. $3.75 to the center was 3.75, right? And to the top, which is with 5 from here to here, that distance is 5. Any question, guys, about it? We found the center of the fixture. Now from there, if I find the center of the first fixture, I can add the distance from here to here and from here to here, which we know, and then you find the center of the second fixture. The same. This will be the same distance for this row. All what you have to add is now we have a 5 here. We have what do we have? We have 7.5 plus 3.27. That will get you the center of the second, and you keep going to the third and the fourth and the fifth. Any question, guys, about finding the center of the first fixture? This is one way of doing it. Yes, Mr. Yu? Go ahead.
Well, inevitably, like, you're doing a commercial building, and you're looking for the center of the first fixture. It all can come in your grid.
Yes.
So,
But this will give you an idea how you're going to lay out your stuff in your grid. So, for example, this is 3.5. 3.5. That will mean this is 4.
I mean, I know what you're saying, but I'm just.
Yeah.
Maybe it's not, but it's like,
Or 3.75. So that's close. This one, guys, 3.75. This one will be close to 4. So what you do then, from this, you're going to go, if you can, just one tile of these, and you put your fixture. If you can't do it, obviously, you might have to move your fixture to match the grid. But lighting, guys, here's what we do with lighting in commercial lighting. Always the suspended ceiling in commercial building and lighting, you work with the architects. You and architects are working together. But ultimately, the architects have the final say. So the architects did not design the grid this different than what your calculation came up to be. You have to follow the architects to the best of your ability. So you might have, Spencer, you have to shift these. This is not rocket science. You might have to shift them to match the existing grid, Now, my question for you would be then, this will be very powerful though if you don't have a grid. What happens if you don't have a grid? Right? You don't have a grid. It could happen easily. You don't have a grid. What would you do if you don't have a grid? If you have a grid, you have to adjust your design to the grid. If I don't have a grid, I have an area with no grid, and these are suspended lights, suspended, open office or open area without a grid, or they don't have to be 2x4. This calculation, guys, does not have to be 2x4. It could be cans. It could be round cans. It could be any type of fixture. The calculation could be round cans. So what if you don't have a grid? Then that will get you the start of how to lay out your fixtures to get the best lighting distribution system. Any question, guys? And really, there's no right or wrong. Mr. Bu, you could have said, I'm going to go by 10x4 and do your design by 10x4. I assure you, the closer the number of the columns to the number of the rows, the better distribution lighting system you're going to have, meaning the smaller the ratio between the maximum, the brightest spot in your room, and the minimum, the darkest spot in your room. That ratio needs to be very minimized. Any question, guys? So if you find the coordinates of the first fixture, then you can find the coordinates of the second, the coordinates of each fixture on every row, and each fixture in every column. Just for the knowledge, if I want to find, I know that this one, guys, the y here that we get is 3.75. 3.75. Let's keep this so it doesn't keep looking at it. So I know coming down, I need to go by 3.75. So all of these are going to be 3.75. These guys are going to be y is what? 7.5 plus 3.75, and you find the center of these. And then the second one will be 7.5 plus 7.5 plus another 3.75. And you start finding the center for each one of these rows, the column of these columns, the rows. We have 10. We said we have 10 up to here, and another 5. So this should be 15. The center of this, the x coordinate. Am I doing the 10, the y? Oh, I'm sorry. Thank you. Yeah, this one would be the x is this way. Okay, so this would be 7.5 plus. Thank you. Plus 3.75. So that's not the coordinate. And the top will be, like you said, these will be 10 plus 5. This point right in here will be 15. Everybody knows that this point right will be 15. How about this point here? 10 plus 10 plus 5, 25. That's how you guys find the coordinates of every single fixture. Brad, this is very powerful, especially if you don't have a grid. Especially if you don't have a grid. How else would you lay them out? If you don't have a grid. If you have a grid, and even if you have a grid, guys, after you do your calculation, you match the grid. Now, this is not rocket science. It's not like I said, x here is 7.5, and we find 3.75. If I can put 3.75, I can just make it 4 and start at 4. So leave one tile like this from here and move. Or if I can't, because it's laid out this way, say if it was half, there's a 2 feet here. Instead of putting, then if you add, this will be 6 feet. And start at 6, I need to start at 4 to center of that. So you might have to shift your fixtures to a certain dimension, just to match your grid, to match your grid. I just want to emphasize that, guys, the end of this fixture is actually minus 1 foot. So it's really, in reality, this is 2.75. So 2.75, here's a 2. Here's a 2. I might have to drop the 2.75 if I want the edge of the fixture. Instead of 2.75, I might have to start at 2. Anyway, if it's a 2x4, very helpful. It helps you. Ultimately, Muhammad, my friend, you need to match, play within the grid if you have a grid. If you don't have a grid, this calculation will get you as close to a great design as you can. Now, Spencer is going to ask me, Chad, how would the software do it? When you guys use the software, you're going to say, how does the software do it? The software, guys, the software that we're using, there are 2 components of it. One component, it's really cool because you can tell only works for square rooms, only for square rooms or rectangle, not any other shape, square rectangle rooms. So if you give the dimension of a square rectangle room to the software and the foot candle and the maintenance factor and all this stuff, it will, and the foot, how many foot candle, it will tell you how many fixture and it lay out the fixture for you. It does lay out the fixture like this. And then that's the component. Then you grab that layout and you drop it directly over your CAD file that you're going to be importing to Visual. And that will get you the layout if your layout is rectangle or square. Now if it's different, guys, if there's a niche over here that cuts through these 2 lights, I might have to get these 2 lights out of the picture. Just get rid of them. So you have to always work, when you work with light, always work with rectangle and square. Make the room rectangle, even if it's not. Do the calculation based on that. And then if my room, there was a niche right here that actually comes all the way up to here, or cuts through these 3, I might have to get rid of these. Just get rid of them. Or so always make the room rectangle, even if it's not. And then get rid of fixtures that, so for example, if I make this room, this does not exist. So that if the fixture was right through the wall, I just get rid of that fixture. Always, when you guys lay out your fixtures, please always work square or rectangle, and then modify the design based on 2 criteria. Number 1, the grid, if you have a grid, and number 2, if the shape is different. What if that was a circle? A circular shape, an arc shape. What if the arc was coming this way? Then you might have to get rid of some fixtures. you know. So, but at least, guys, what I like about this is at least it gets you some type of a layout to start with. Some type of a layout to start with. Any question, guys? Any question about the layout? Any question? And we chose a bigger fixture. Obviously, this could apply for 2x4, 2x2. It could apply for circular fixture, any shaped fixture, as long as Spencer always capture the center. The reason why some people, guys, do the calculation based on the edge. I'm going to do my calculation based on this edge here of that fixture. Well, what if that fixture was not a 2x4? What if it was a round fixture? Always do your calculation based on the center of the fixture, because if you capture the center, you can capture the parameters of that fixture. Any question, guys? Any question about that? Camille, my friend? Jim, Mr. Bab? No? Okay. So I want you guys to take this, keep this one for next week when we lay out the fixtures. We're going to treat the room as rectangle or square, even if it's not. We drop our design on it and modify, get rid of certain fixtures. Otherwise, Brad, if you don't do it this way, it's like a trial and error. Well, let me put the fixture right here and then move them, and then let's try and see what calculation we come up with. But that's at least give you the best scenario, and then you might have to modify. I'm not saying that you don't have to modify it. You might have to modify it, and you will in real life, but at least it gets you the best shot at it. Can you tell your husband if they do it this way? But don't. What do you guys do? What does he do?
Visual.
Yeah, but when visual, you're going to see how visual work though.
Yeah.
This will help you lay out the fixture in visual. Because visual doesn't tell you guys how to lay out the fixture. Visual, if you lay out the fixture, it does the calculation for you. But how do you lay out your fixture? Where do you start? How do you start in visual? Visual doesn't tell you how to start. You know, I guess you can start randomly, just putting fixtures everywhere and evenly dividing them and run the calculation. That would work. But at least this gives you, if you know the number of fixtures, that will give you a good calculation. Again, visual also, the little component that they have to, if your room is rectangle or square, it will do layout for you. Really nice. It do the layout and then you drop it on the CAD. I'll show you how to do that. But how does visual do it? Most likely, you're going to see, always try the columns, the number of columns, number of rows as close to each other as practical. Okay, so that's basically what I want to talk about this one. Any question, guys, about this? Any question about laying out, finding the average, and laying out the fixtures? The second thing, guys, I want to talk about, we kept talking about maintenance factor. I want just to emphasize a few maintenance factor things before I do. You're going to hear the word maintenance factor. Maintenance factor. I spelled it right. Of course, no. Has to be maintenance factor. Maintenance factor. Here's the definition of maintenance factor, guys. You take the maintenance factor, it's D, DF, and and I will define this in a second, is defined in your book too. LMF, you're going to hear a lot about these. LLD times TF. This is how they calculate the maintenance factor for a fixture. Now what the heck are all these DDF and LMF and LLD and TF? DDF, guys, is their depreciation factor. So let's say DDF. This is stand for dirt depreciation factor. And these are also in your book. Dirt depreciation factor. What's a dirt depreciation factor? How often do you clean your fixture? If you clean your fixture more often, that factor could be 100%. If you don't clean your fixture at all, that factor can go all the way down to 10%. Okay? So the factor is cleanness. It goes from 0% all the way to 100%. This is clean. This is dirty. Dirty. So that's their depreciation factor. The second factor, guys, any question about this? How often you clean it? LMF. LMF. LMF is lamb mortality factor. Lamb mortality factor. How long does the lamb last before it dies? Lamb mortality factor. It's also a function, Spencer, of relambing. Do you relamp more often? Every 2 years you go relamp the whole building? Okay, again, this also goes from 0% into 100%. And this is relamping a lot. This is no relamping. No. You just put them there and let them sit there forever. No relamping. So they die more often on you. Any question, guys? So the function L, lamb mortality factor, they will die. Fixtures, lamb will die on you. But if you relamp them more often, then they're not going to die on you. So if you don't relamp, you just sit them there until they die, you're going to go, I'm putting 0, guys. It's really not 0, but kind of that's the extreme. 100%. Every 6 months, every 1 year, you go relamp the whole building. So that will put you 100%. They will never die in you. Will never die in you. Any question, guys, about the relamping versus no relamping? Any question, Mr. View? Can I switch to the next one, Mr. Rebab? Good. The second factor, guys, and these are really good to know. LLD. It's called LL&D. This guy stands for lamb plumbing depreciation factor. Lamb plumbing depreciation factor. Lamb plumbing depreciation factor, again, it goes from 0% all the way to 100%. This is done by the manufacturer, Brooks. What happened to the lumens when that lamp ages, based on the design of the lumen? So this guy can give you 3,000 lumens day one when I power it. 5 years from now, do you expect that lamp to give you the same 3,000 lumens? You would hope not. I mean, physics will work. So that's basically, I always say, this is manufacturer factor. Manufacturer factor or product factor. Really, every lamp comes based on the design, based on the physics involved in it, based on the gases treated in this lamp. They assign a lamp depreciation factor for it. Okay? Manufacturer factor assigned to every lamp. So assigned to lamp. Assigned to lamp. So you get it for every type of lamp, fluorescent, brightness, discharge, and so forth. The last one, guys, is TF. TF. TF is called temperature. 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 Factor. Temperature factor, I want to say here, C graphs. C graphs. There's a temperature, if the fixture, guys, is rated to work on say 30, or let's just say Fahrenheit. If it's rated to work at 78 Fahrenheit and you go put it at 110 Fahrenheit, the amount of the temperature factor will go down, and that will be taken into consideration with the amount of light coming out of it. In the book, guys, they have a graph that can get you some type of an idea of lumen depreciation factor or temperature. If you guys look at page 42, lumen characteristics of fluorescent. This one for fluorescent. Every fixture has its own. Fluorescent lamp with temperature variation. Look at the degrees, plus or minus 100% plus. So it goes, if you go, and this percentage of mean rated lumen, how it's going to be affected at 40. If you look at plus 40, these are in Fahrenheit. Plus 40, you get 100% out of lumen. So if it's 3000 at 40 degree Fahrenheit, you get exactly 3000 lumens. If you increase it to 60, plus 60, you're going to get the percentage of lumen rate of mean rated lumen is going to go up, and you can see at a certain time it starts going down. As the temperature goes higher, it goes up with temperature for a limit, and then it goes down again. If the temperature is low, you can see that that fluorescent light at minus 20, you don't get a whole lot of lumens out of it. Anyway, so every fixture, this doesn't mean, guys, apply for all fixtures. It's just an example of how the temperature can affect the fixture. Brad, typically the temperature, if the temperature is very low, the lumens will go down. If the temperature is very high, the lumens will go down. So there's kind of this range of temperature that can give you the ultimate lumens out of fixture. The ultimate lumens. Any question, guys? I'm sorry, Spencer? Any question about these factors? When you put all these factors, guys, together, and you multiply them, you get the maintenance factor. You put them all together, multiply them together, you get what we call the maintenance factor. Long story short, and in the software, guys, LLD, light lumen depreciation factor, you put this one. There's a couple of other factors the software, not all softwares lump sum them like this. Sometimes they allow you to go individually and assign these factors for you. So, but be aware that these are factors that can reduce the amount of light that's coming out of your fixture. Reduce the amount of light that's coming out of your fixture. Any question? For the test, for Chad, I will give you these factors. You multiply them, you calculate MF. For real life installation, the software that we're going to be using, guys, there's a couple of buttons that you have to hit to go assign an LLD or LMF, some of them, or DDF individually. You have to assign them. And if you don't know, they give you typical, guys. That's a nice thing about these softwares. If you don't know, where am I going to be? What type of a DDF? It depends on the type of the occupancy. So they will tell you, if you're in manufacturing, dirty manufacturing, this is what you typically use. So they give you a lead. Otherwise, we wouldn't know what number to put DDF. So they give you dirty, very dirty, less dirty, and so they have a whole lot of lists, and you just basically pick to the best of your ability of judging that particular application. Temperature factor, I have to admit, is not too much involved in this calculation. I haven't seen a software that assign a temperature factor. It's usually common sense. Most of the manufacturers tell you it works from minus 20 all the way to 120 Fahrenheit, or something similar to that. Any question, my friends? Any question about that? So that's where the maintenance factor is. Now, DJ, if you don't take the maintenance factor into consideration, and you do your calculation, guys, based on 100% maintenance factor, great. When you build the building, install it, commission the building, turn the switch on, and you measure the amount of light you will get, for example, 80-foot candle. That's what you designed for, 80-foot candle. 6 months from that day, 6 months from the day of commissioning the building, right? You go measure the same distance, the same stuff, and you're going to end up with, instead of 80-foot candle, you might end up with 60-foot candle. So people are pissed off at you 6 months. Well, the quality went down. Why? Because of all these factors. The lamp is aging, so the lumen went down. Because it's dirty, they don't clean it. Because of multiple factors. So to cover ourselves as engineers and designers, guys, we always basically take this into consideration day one, and we design the system, and then 6 months, a year from now, we're almost guaranteed that you'll be around 80. Here's the catch-22 though. When day one, when you design the system, guys, and if you did the calculation based on 80-foot candle, and you go really physically measure it day one, when you power it, you might end up with a 100-foot candle, very bright day one. Why? Because of all these derating factor you added. But over 6 months, a year, you're going to average 80-foot candles. So this one thing you guys have to explain to the customers as you walk in. They might be pissed off at you, very bright in certain areas. You have to explain why it's very bright, even though I calculated for 80-foot candle. It's very bright, more bright than 80-foot candle. Because you're going to tell them that we took into consideration maintenance factor, meaning we want to guarantee you this 80-foot candle 6 months, a year from now. So if that flies. If it doesn't fly, and I want you guys to ask Davis and Associate when they come, they take a couple of factors into consideration. They always get into this thing, is it's too bright. Yes, too bright, because I'm designing not for day one only, for 6 months, a year from now. Very, very important in terms of light. Unlike receptacle here, the load in the receptacle, you would hope, unless substantial things change, it stays the same from now until a year or 2 years. And if the load changes substantially, you have to change the circuit and so forth. But light, by design, because they have chemistry working on them, they go down. The lumen goes down in them. Any question, my friends? Any question? I hope that will help you, Mr. Bew, as you use the software. When you see LLD in the software, now you'd hope what this LLD means. There's a couple of other factors that I didn't talk as about, is the ballast, the life of the ballast, and all this good stuff. We take into consideration. But I've never seen a software, ask the lighting guys, gurus, when they come here, a software that take the ballast into consideration. It's part of the whole relamping business. But of course, if the voltage in the ballast is too high or too low, that will screw up your ballast. Well, guess what? If the ballast is screwed up, the light is going to burn. If the light is going to burn, your mortality factor is going to go down. You know that. Which one is the mortality? Lamp mortality factor. That factor is a function of the ballast. Right? The ballast, good ballast, will make the lamp live longer. Bad ballast will make the lamp live shorter. So it's kind of accounted. The ballast is accounted right into the LMF. At least the way I understand it. Any question, my friends? I'm going to give you guys 5 minutes, and when we get back, I'm going to do 2 examples about point-to-point calculation. This is the average. So Spencer, the average is very easy. Plug in the numbers, play with it. And the point-to-point calculation, guys, is also very easy. You're going to see one formula, plug in a couple of numbers, and play with them. So you can have 5 minutes, and let me do an example here.
What are we going to be doing tomorrow?
I'm going to go over a couple of chapters in the other book.
In the theory book?
Yeah. Why? You have anything?
I had to, I'm gonna go to a funeral.
Okay.
I just found out about it like right now.
Oh boy. A relative?
No, it's a friend.
Sorry. Okay, so it's me.
We're just going to tears.
Okay.
He'll run one for today. Woodson will crack into the middle. He'll get, he'll get 15-minute penalty, but then he'll get. Um, Sunday 3:30. That can be a bloodbath.
You're calling it that close.
Calling what that was.
24, 21? Or is that you?
No, that's me. New Orleans is gonna crush.
Seattle shouldn't be in there.
It's not projected, it's just, these are picks. Pick up challenge. Johnson's girlfriend. Caesar edge. Being a doctor, you get all that.
Okay, are we guys here? DJ's here? All what it counts. Dangerous, huh? Okay, can I have your attention? Where's Mr. Rebel? We can't start if Mr. Rebel is here. What's going on
I'm
here?
stuck in the elevator.
Stuck? Serious?
No.
I can't aggravate any one of you guys. Now with all these shooting going around, I have to suck up to you. Everybody's gonna get A, okay? Did you guys hear me?
Say
On
okay.
record? I have 3 kids, guys. I don't want to face the Lord yet. It's not time. So DJ, huh? Don't be mad at me with that hook of yours. We'll see. Okay, if I can have your attention, guys, this is very simple if you follow with chat. If you don't follow, it has a tendency of complicating your life. It really is. So the reason why I want you to follow with me, because we're going to simplify it. For one reason, Spencer, because I really care less about actual calculation using this method. For one reason, we're going to use visual. Visual will do this calculation much better than we do. The only reason, Mr. Rebab, that I like this point-to-point method, so you guys can appreciate what visual does. That's the only reason. And I test you on it first too. So hopefully you know when we say point-to-point calculation, when you see visual is giving 53.3 foot candle right on that wall, you say, oh yeah, now I know how it's calculated, but I really don't want to do it. It's too much work. Okay. Here's the situation, guys. I do have, let's just talk about the scenario that we have. I have a high pressure sodium. HPS is a high pressure sodium, 150 watt lamp. Okay? Sitting in one area and mounted at a pole. The pole that's mounted at this 10-foot pole. Okay? You can put it as high as you want. 10-foot pole. And I need to do the calculation at 3 points. I need to find the foot candle at 3 points. Number one, right under, I'm recording, yeah. Number one, right underneath it. What's the foot candle right underneath it? Number two, at this point, and number three, at this point. They're going to ask me, Chad, what is this point and this point? Let's do it. Let's do the angle. So I'm going to go and find, and you can find the distance. Let's pick, this looks to me like 45. Let's do the calculation based on 45 degree. And this angle is slightly bigger. So I'm going to go instead of 45 at 65. 65 degree. Okay? So I went 45 degree. And I want to find calculation. You can find this distance from 1 to 2. You can do the math and trig and find the distance. But I really care less. I want to find the foot candle right underneath the fixture and the foot candle at angle of 45 degree and at angle of 65 degree. Here's the two formulas, and I can prove it if you want to. If you want to get it to the trig, I can prove it for you. But if you don't want me to get it to trig, just take it from Chad and move on. Two formulas that you need to understand. Formula number one, as the foot candle, I'm going to put the formulas right here. Foot candle equal CP. CP is candela power multiplied by cosine Q. What is the Q? Q is right this angle divided by the distance squared. Let me repeat myself here. Foot candle at any point equal the candela power at that particular angle, multiplied by cosine that particular angle, divided by the distance between the light and that particular point. One more time. This formula says if I want to find the foot candle at point 2, here's how I do it. First, I need to find the candela power from a table. We have a table in the book. that can give me the candela power at that particular angle, which is 45. Then I need to multiply it by cosine Q, which is that particular angle, divided by the distance between the light and that point that I need to calculate for. The distance between the light and the point that I need to calculate for. This is the formula that I don't want you to use, the one that I showed you. This is the formula that I don't want you to use, but I want you, when you read the book, you're going to be seeing this formula all the time, guys. The formula that I want you to use, it's simpler, and you can prove it by math, but unless you challenge me, I'm not going to go there, unless you challenge me. And I want you to correct the book, because it's in the book is slightly different. So foot candle, here's the one that I want you to remember. Foot candle equal, the same thing, guys, candela power times cosine Q raised to the power 3 divided by H to the power 2. It's really the same formula, but with the trig, guys, we made the formula a function of the height of the fixture, which is awesome. Why it's awesome? Because now I don't have to find the distance here. I don't have to do the trig to find the distance, right? If you use this formula, guys, you should come up with the same answer and try it. The two formulas give you the same answer. This one is the best, I believe, because then you don't have to find the distance. All what you have to do, here's the height of the fixture, here's the angle. I can find, if I know the height of the fixture and the angle that I need to find at, I can find the foot candle at any point around this fixture. That's why this is powerful. Do me a favor, in your book, page 41, please write h squared where it's fig 4.2. The first formula says horizontal foot candle, HP. It's the same formula except right at the bottom, could you please add h squared? And if you don't believe me, Brad, please do the math and you'll come up with the same thing. I've done it many times. It should be h squared. Okay, if anybody wants to do the trig, it's really trig. Trying to find, here's how we do it. You find the cosine Q is the adjacent over the hypotenuse. And then you substitute D here, you square it, you flip it, you end up with this formula. You can prove it. I can prove it to you, but I don't want to do that unless you want me to. Okay, so that's the formula that we're going to be using. These two formulas are identical. These two formulas, DJ, my friend, are completely identical. One of them, this one is superior because we don't have to find the D. It's always a function of the height. And Ryan, I always know the height of the fixture because I'm the designer. It's 33-foot pole that I'm going to put this fixture at. But you don't always find the distance from the 33-foot pole light all the way to in the parking lot. I know the angles. I can find it at different angles. Anyway, so the second one is the superior one. So please, could you please highlight it? And that's what I'm going to be at least testing you on. And if anybody wants to do this, why the two formulas are, it's actually cosine Q equal H over D. If anybody want to find the D equal H over cosine Q, plug the D in here, you end up with that formula. Okay? Just FYI. These two together bring this formula down. Okay. If you believe me, let's just continue on doing the calculation. Anybody disagree? You want me to do the math on plugging these in and find this? Say no, Holly. Okay, thank you. Somebody has to say no. Any question, guys, about this scenario? You can use it for any lighting fixture. You need to know the height and the angle that you need to find a foot candle. So what I'm trying to find here, guys, I'm trying really physically try to find the foot candle here, the foot candle here, and the foot candle right here. Okay? One thing is missing from here. One thing is missing from this formula, guys. Is missing from this formula. Anybody can tell me what's missing from this formula? We just spent some time about it. All these factors, right? Maintenance factor. One little thing missing from this one, we're going to use it as right in here, maintenance factor. And maintenance factor. Just right there, maintenance factor. It's a derating factor. One little thing missing is the maintenance factor. You don't have it in your book because they're assuming the maintenance factor is 100%. That's why they don't put it. But later on, we're going to do calculation, guys. Maintenance factor has to be given, which is a lump sum of all these babies. Okay. Any question, guys, about this? For the example, let's assume the example that I have that maintenance factor is 90%. Just for this example, okay? Because I want to do some calculation. Our maintenance factor is assumed for this fixture at this location, at this application, at this occupancy is maintenance factor is 90%. Okay, let's go find the foot candle at point 1, 2, and 3. Very easy, guys. Very easy. Everybody knows what we need to do. We need to find the foot candle at point 1, then at point 2, then at point 3. Now here's a question for DJ. DJ, do you think if this angle is 45 and this angle is 45, do you think the answer for 3 and 4 would be the same? Anybody can help DJ? Identical.
45.
If both of them are 45, yes, symmetrical. They're symmetrical. That's a nice thing about this method. If the angles are the same, the calculation will be identical. So if I have 45 and 45 here, just by looking at it, this point and this point foot candle will be identical. But I intentionally made them different just because we need to do 3 calculations. Just to bug you guys. Any question, my friends? Mr. Irbab, you're going to be asking me, Chad, where do you find the CP for these fixture? Every fixture has a schedule, isometric curve. Every fixture has an isometric curve that can give you the CP for that particular fixture. Thanks God, we don't have to worry about this, and we have an IES files that we can pull. So Brooks, when you pull an IES file for an IED is a LED. IEDs. Oh, that's powerful. LEDs, if you pull an LED IES file, that's exactly what you're pulling. You're pulling all these isometric data. Any question, guys, about this before we go ahead and do the calculation? Camille, my friend, Jem, Chanel? No? It's not too, is it good, bad, ugly? Okay. Well, you need to know this formula at least for the test. I mean, but I hope you guys appreciated the one who will do some lighting designer. That's what the software is doing for you. Okay, let's go ahead. I want you to remind me of the data as we go through. All right, so I'm going to do the calculation. Did you steal my marker? No, nobody stole my marker. Okay, foot candle at point number 1. Foot candle at point number 1. That's what I'm going to calculate first. Point number 1. Foot candle at point number 1. Right underneath the fixture. Right underneath the fixture. I want you to look where point number 1. Right underneath the fixture. So Muhammad, and anybody can help Muhammad. What's the angle right underneath the fixture? 0. Thank you. What's the angle right underneath the fixture? 0. We're looking at these angles. If this hypotenuse keeps moving all the way until it lines up with the edge, that's zero angle. So everybody knows that the angle is 0. Okay, so I'm going to say Q. First of all, Q, I'm going to call it Q1 equal 0. Right? Everybody knows why Q1 equals 0 right underneath it. Okay. And Q1 0, if you take this one to Fig 4.1, CP for this particular angle is 650. Can you guys find that CP is 650? CP is 650 candela power. The candela power at angle 0, right in here, from this schedule, at angle 0, the CP is given to you as 650. And I'm looking at page 40, guys. If you want to follow up with Chad, this is in page 40. Fig 4.1, page 40. Page 40. Page 40. This is the data that I'm pulling. Any question, guys? At angle 0, the amount of light that's going to hit the angle 0 right underneath the pole is actually 650 lumens, lights, units. One more time. At point, if you guys are confused here, point 0 is right here. Camille, my friend, right underneath, which is 0 angle, right? Because it's 0. Then, I know why it's 0, because right underneath fixture. Then I take the 0 angle to Fig 4.1, page 40, which is the isometric curve for this fixture. That will get me a CP 650. Eric, without this info in Fig 4.1, you're dead. You can't do anything. That's why this information is tedious, because every fixture has to have this information. Thanks God for technology. Now we have the IES files that pull all this information directly into the computer and sucks it in. But in between, Chad will torture you with a couple of examples. Okay. So here's the foot candle for point number 1. Then let's start putting the CP. So CP times cosine 0. Let's say cosine Q to the power 3. Don't forget, divided by H2. Let's plug in a number. CP is 650 DJ. Cosine 0 to the power 3 divided by, what's the height? The height was 10 for this fixture. So 10 to the power 2. Okay, so if you guys do the math on this one, 650 times, Ryan, I'm going to test you in trick. Cosine 0 is 1, right? Because don't believe me, use a calculator. Cosine 0 is always 1. So 1 divided by 10, by 100. And could you please give me the answer? That's easy. That's 6.5 foot candle. So Spencer, right underneath the fixture, you have a 6.5 foot candle.
The rate right away?
The rate. Oh, I'm sorry. I didn't put the derating factor. I'm so sorry. It's actually, you're right. I forgot the maintenance factor. Multiply it by, what was the derating? Spencer, 0.9. So can you guys give me that one then? Yeah, I have to derate. The maintenance, I keep forgetting the maintenance factor. Maintenance factor. Okay, so based on the derating, thank you. What would that give you, Spencer?
Yeah, 5.85.
5.85, 5.9 foot candle. 5.9 foot candle. Very good point. The rate. That's why day 1, Spencer, you could have gotten the first number if you didn't derate. And then the people will say, oh, it's too bright, because we're taking that into consideration, and in the future it's going to go down there. Okay, 0.9. So 5.9. Any question, guys? That's like right underneath it. This point, guys, if you look at it's called nadir point. I don't know if I'm saying it right. Nadir, nadir, or nadir. So this point, this particular point, I want you to highlight. This point here, just that particular point is called nadir. Nadir point. So, DJ, if you hear somebody saying, I want you to calculate the foot candle at nadir point, this means right underneath the fixture. Right at 0 angle, basically at 0 angle. Nadir point, okay? Just a term. I think the guy who invented it or somebody.
What was that? 650 times what? 1 point.
0.9, this one?
Yeah, right there.
This is 0.9. This is the maintenance
1 times
factor.
0.9.
1 times 0.9, yeah. Did you come up with a different number?
Oh, I just can't read it.
Okay, sorry. 0.9. Any question, guys, about that? .9. A little bit better, I think. 5.9 foot candle. Any question, guys? That's a nadir point right underneath the fixture. Right underneath the fixture. Okay, let's go find it for the other 2 points. Very similar, guys. Very similar, very easy, straightforward, no gimmicks. Any question, Jim, my friend? If I give you all this information, would you be able to find that point? Straightforward. Everybody has a calculator that has cosine sine, right? Scientific calculator, I hope so.
I will.
You
My
will?
battery died.
Okay. The second point that we need to do is foot candle at, this is my at, point number 2. Okay, for point number 2, Q for point number 2 is 45 degree, right? 45 degree, that's Q. Everybody knows where I got the 45 degree? 45 degree. I hate that. Q equal 45 degree. 45 degree. I suppose. Okay, if you take this one to, what was the fig again? Take it to 4.1, 4.1, page 40, fig. Fig. So, if you take it there, the 4, at 45, guys, what is it? 1208. So, candela power equal 1203. Everybody knows where I got the candela power for this particular angle. This is from fig 4.1 and in page 40. Okay? Done. Done. Right? What's next? Next is foot candle equal. Remember the formula, guys. I wrote it multiple times. It equals 1203 times cosine 45 raised to the power 3 divided by 10 times 10. So I need somebody, don't forget the service factor too. 0.9 multiplied by 0.9. Okay, who's going to give me that number? 1203 times. What's cosine 45? 0.707. Raise it to the power 3 and divide it by 100. Don't forget to raise to the power 3. Everybody knows how to raise to the power 3. Multiply itself 3 times. If you don't know how to use using calculator, what's the answer? Don't forget I always forget the 0.9. I need to, 3.8. 3.8. I need another gentleman to agree or disagree. Anybody came up with something different? 3.8? Okay, 3.8 it is. Reject. Any question, guys? So 3.8 foot candle. 3.8 foot candle. At 45. At 45, 3.8 foot candle. What was the first one? 4.9. So it's a little bit less. We're going further away. Yes, sir.
What was it 10 times 10 this time?
10 to the power 2 is 10 times 10. Yeah, how did they do it the first time? I put it 10. Yeah, 10 squared. Yeah. 10 times 10. Okay, sorry for that.
I think Q 7071.
So maybe we should just stick with the format here, guys. Don't confuse people. 10 to the power 2. I'm sorry, did you say again?
How do you cube it 0.771?
It depends on your calculator.
Do you have a y to the x clock or do you have a cube button?
Shift. Some have shift 2.
Oh yeah, I got that y. Okay.
So you just take the answer for the cosine, y to the x, 3,
Okay.
and then you should get like 0.35.
All right. Any question, guys, about this? So let's go to the last one. Foot candle. Foot candle equal. Foot candle at. This is foot candle at what's the angle? At point number 3. Q equal 65 degree because Chad says so. Or that's the point that I care about. Q equals 65 degree. And from this you go to fig 4.1 page 40. And you're going to find, what's the
3675.
3675. Thank you, my friend. CP candela power 3, 6, 7, and a 5. Very important number. Now, Camille, without this number, you cannot do anything. Did they do it? 3675. I did it right. Great. When you laugh, I always think I'm doing something wrong, man. Don't scare me. And it's all these shooting. Now I'm shaking here. Okay. 3675. Any question, guys? Everybody knows without that fig, can't do anything. This fig actually translates into IES file. When we go to the software, this is your IES file. Without it, you're dead duck. Okay. Let's plug the numbers. So we're going to have put candle equal, these are red, 3, 6, 7, 5 times cosine 65 to the power 3, and I always times 0.9, divide everything by the height, which is 10 to the power 2. Any question? Okay, I need 3, 6, 7, 5 times, what's cosine 65? Don't do your calculator.
Okay, I got the answer already.
What anybody care of the cosine? How much? 0.4226 raised to the power 3, and don't multiply by 0.9, divide everything by 100. 0.4226 to the power 3 multiplied by 3675 times 0.9 divided by 100. Answer? 2.5, thank you. Answer is 2.5. Anybody disagree? 2.5 foot candle. The answer is 2.5 foot candle. Did you multiply by 0.9? I just take it. Yeah. 2.5. But okay, thank you. Any question, guys? So we found foot candle. Can you guys see that this is not an average now? This is a point-to-point method. Now, Ryan, if I want to torture you more, I would add another 16 points with another 16 angles, and I ask you to go do the calculation. Just over and over. Now, what the beauty about visual, guys, thanks God to the, imagine they used to do it by hand before the computer. They used to do the point-to-point calculation by hand, old-timers. And now the beauty of the calculator is you put your fixture and all these mapping behind the scene, and it does the calculation. If it defaults inside, visual defaults 2 by 2 feet. Every 2 by 2 feet, it takes a point, a grid, 2 by 2 feet, anywhere, vertical or horizontal. 2 by 2 feet, and every 2 by 2 feet grid, it puts a calculation point for 2 by 2. You can make it happen, but the more points you calculate, the longer it will take it. Inside, I believe the default is 2 by 2. Outside, I can't remember. It's more than if you're doing parking lot. You can change these defaults too. Can you guys see that the further you go away from the fixture, what happened to the foot candle? Keeps going down. Keeps going down. The foot candle keeps going down. And it makes sense, right? Because you're moving away from the fixture. You have less light. You have less light. Moving away from the fixture, you have less light.
I have the same one.
The only thing, guys, we did all this exercise. The only thing that we didn't, there's another factor, the rating factor. There's a few derating factor that they can take. Let's go back to our formula, the beautiful formula that we have. There's a lot of other derating factor they can add. They can add a maintenance factor here. We did. They can add something, another guard factor. If you're outside or inside and you need to guard that fixture from physical damage, and you put that little basket over it, what do you think that's gonna do to the light? Shield some of the light. So they add another factor that's called guard factor. Another fact, all what you do is just you're adding, you're derating. And another thing, guys, that you can do is if you have coefficient of utilization, you have a coefficient of utilization, the fixture itself, we didn't say anything about coefficient of utilization. We're assuming this fixture is 100%. So sometimes they add to this formula, especially if you're inside the building, if you're inside the house, they add another factor that's called coefficient of utilization. Another factor you multiply by to get your coefficient of utilization. Okay.
Do we need to do that one for the test?
But for the test, guys, if I give you the maintenance factor, coefficient factor, and guard factor, all what you have to do is just multiply them by here. Keep adding, multiplying them. Most of the time, I will give you the maintenance factor, that lump sum, and we assume it's coefficient of utilization. It's 100% because there's no walls or ceiling or anything.
Guard factor,
I can't figure it out.
factor also.
Coefficient of utilization, CU. Coefficient of utilization.
You can do it.
The CU factor
Calculator on your computer.
Coefficient.
of utilization.
Let's see, this is the code's on 45, which it is.
Could it be more than one?
Could it be more than one?
Square cube.
No. 2 to the 1 is 100%.
Calculator has the next cube.
So you never have a maintenance factor or a shield factor? Just calculate on X.
If you don't, just don't put it there.
Oh, but
Assume it's 1, 1, 1. If it's not there, if I don't give it to you, it's assumed 1. Like power factor. If I don't give you the power factor, what do you assume? It's always 1. It's like a power factor.
So you'll never have the two of them in at once.
You could have the 3 of them.
Oh, okay.
Oh yeah, you could have
We say
all of
if
it.
you doesn't give it
If
to
it's
you,
not
then
there,
it's
you
one.
But if I don't give it to you, it's assumed 1.
It's not listed.
What should we get?
3.16. That was for the second calculator.
Yeah, that's what I'm gonna suggest.
Any question, guys, about this? Any question about this calculation? Any question about this calculation? So that's basically for your Ryan, my friend, I might, as I said, add other factors. If we put this fixture in a room and there's walls and geometry around it, which is coming, then you add the coefficient of utilization based on the geometry. And if you have a guard on it, you add another derating factor. If you don't have them, then assume it's always 1, like a power factor.
When we start up with your function, it will be first. Just enter. 0. Just hit 0. 45. Times. Which is your answer. Oh yes, I'm sorry.
Okay. The other thing I don't want to do another example, but I want to bring to your attention, guys, if we have a parking lot like this, and I have all these car spots.
That's like dump truck parking on those sizes.
Yeah. And I decided to put a lighting fixture here and a lighting fixture, just for the heck of it, lighting fixture. These are lighting fixture in the parking lot. And we're going to get into the parking lot, guys. And lighting fixture number 1 has a foot candle around it, and another one has, each one of them will be overlapping. You're going to see how we do this one. And these are 4 lighting fixtures or luminaires in a parking lot. Each one of them, guys, is going to have a foot candle curves around it. So the only thing I want to, and let's assume just, and this is an example in your book too, let's assume that every one of these green circles around it, let's assume that right at this point here, it was 0.5 foot candle. And right at this point here, it's 0.5 foot candle. Anybody can tell me what this point here, that mixture of both of them? Thank you, 1. They add each other's up. They add each other's up. When these curves intersect each other, they add each other up. So if this circle represents every point that has 0.5 foot candle around that light, if you have 2 lights side by side, the 2 curves overlap. Every time they cross each other, they add each other's up. So at this point is actually the foot candle is 0.5 plus 0.5 equal 1 foot candle. I want to make sure that everyone can see that. Can you guys see that? So and just you can extend your imagination and you can imagine there will be always curves all around this fixture. Curves all around this fixture, right? It's not just one curve. As the further you go from the fixture, the smaller the foot candle. And all these curves, what do? They intersect. All these curves, what do? They intersect each other. But at the point of intersection of a foot candle of 2 fixture, they add each other's up. They add the light. Okay? So the same token could be at this point, Mr. Rabab, right here. The same token, if I want to find the foot candle based on these curves, I would go 0.5 plus 0.5. That will get you 1 foot candle. Now, Spencer, if I have a 3rd fixture to make things worse, say I have another fixture here, and that curve of that fixture also landed here with another 0.5. Becomes 0.5 plus 0.5 plus 0.5, 1.5 foot candle. And that's how when we next week, guys, when we do parking lot calculation, you're going to have an isometric curve around every fixture, and you're going to physically, mechanically grab these curves and overlap them. We slightly make them overlap, guys. Overlap them, because that will give you the best distribution in the parking lot. So you grab, here's the light coming out of this fixture. Here's the light coming out of these 2 fixtures. You usually don't put them like this. You want to grab them and make them slightly overlap. Not too much, slightly overlap. And you're going to see when might not make a whole lot of sense, but when we use visual, it makes a whole lot of sense when you grab the isometric curve of every one of these fixtures and make them slightly overlap to get you the best distribution.
What about like to the left of it, like where it's overlapping and almost the light?
Where? To the left here?
Like where the green one is on the second one. Yeah, right left a little. Right
Here?
there, yeah.
At this point? Yeah, at this point, of course, this will be overlapping with another curve, and it would add each other up. So, see, at this curve right here, let's say that curve was that curve was 1 plus 0.5 becomes 1.5. It's not the same curve, it's a different curve, but it adds each other. Yeah, it keeps, when it overlaps, guys, everywhere here, let me just use the red, everywhere in this area here, it will, not just at these points, everywhere here, it will be added up. The light from the 2 fixture will be added up. So if I look at this fixture, that particular area, the red area that I'm showing you, it's going to get light from both fixtures and it's going to add up. I took 1 point, DJ, just 1 point to illustrate, but in reality, that overlapping, meaning you add the light coming from every fixture. But you can tell if they don't overlap in this area, obviously, this means the light coming from this fixture at this location here is neglected, right? It's not a lot because they're far away from each other. That's what I said, guys. You make them overlap slightly so they can add each other up. If completely overlap, then every single point is going to be added from everything in the fixture. You're going to end up with a lot of light. So, And the reason, Spencer, why they overlap it, because what's the worst scenario that I want to live? I want to live this area right in the middle is the furthest from both of these fixtures. That's the worst scenario. So if I don't overlap them, it's going to be dark. So what they do, they overlap them slightly, so that furthest point from the two fixtures, when you overlap them, it gets more light, a little bit more from each one of them. It adds up to an even light. You even the light. The same thing, guys, over here. This area, the overlap area here, it's going to be added up. The overlap area here is going to be added up between the two fixtures. And there's an example in page 47, guys, that illustrate in the book what we're showing here. Any question, if you have foot candle coming from two fixtures, three fixtures, four fixtures, at the same point, it adds up. At that particular point, it adds up. It adds up.
So each one of them rings inside that one might be 0.6 going in and
Yep.
0.7 and then
Yes.
add them.
Add them up. Yep. That's how you get your. When we use visual, you're gonna see how that area becomes really good lit because of the overlap. The worst thing that could happen to you is you have to have the cutoff though. This 0.5 foot, the cutoff. I don't want any point to be less than 0.5. In a parking lot that's come in, sometimes they use 0.25. I want every point to be at least 0.5 foot candle. That's why I choose a 0.5 foot candle. It could be higher than 0.5, but I don't want it to be smaller than 0.5 foot candle because it's dark. So you use that to cut off, and then you overlap these two curves of the cutoff.
What about
Why do you think I didn't make this one 2 in a parking lot? 2 is too much light in the parking lot. 0.5 is your cutoff, meaning, and I guarantee, in this case, guys, I'm guaranteed that everything within this green circle is 0.5 or more, right? Anything further away, this way, is actually less than 0.5, which I care less about in my design. Yes, sir.
What about like isn't there some like lighting law or something where like if you had an apartment building right there and you
Yes,
had a
Bill.
bright spot, like
Spell. They have 90% cutoff. We'll get into that one when we do it. A lot of them, guys, yeah, you do a 90% cutoff. If you use them this way, you want the light to reach the end of the parking lot, but not further. So by design, you can either beam it, you can beam the fixture, adjust the fixture to shoot right at the parking lot and not further away. And they have a 90% cutoff. A lot of them, it sits like this, and it actually shoots, and you can adjust it with the height to shoot to center of the parking lot. And at the end of the parking lot, you don't want it to be more than, say, 0.25. So by calculation, when you point it at the end of the parking lot here, where there's an apartment here, I can design it that it doesn't go more than 0.25, which is not a whole lot.
is there a law or is there how do they?
I know in Bloomington you have to consult with the city when you design.
Oh,
There's city by city. They're very strict about parking lot. They come up, the inspector will come up with lighting designer and they measure it. Normally, if somebody complains or if they're doing inspection,
oh,
so it's you don't want somebody to go, but parking lot point most of the time minimum is 0.5. You want a 0.5, but I don't want 2 foot. If I'm living here, I don't want a 10-foot candle right in the front of my yard, and I can't sleep at night.
There's an essay over on Lake Street, where I live, and when you drive past it at night, it looks almost closed because right behind the essay, all the way around, is residential houses. So actually, in the parking lot, it's really bright, but when you drive by it, it looks.
oh,
By
pretty-
design,
it's
cut
a
off.
good example of
Yeah.
like you can't
Yeah.
have too many whatever. So.
Yeah. You're gonna cut out by design. I want to leave it to the expert guys. When they come, there's an associate. Ask about cutoff. 90% cutoff. It shoots right. You can design to shoot right at the end of the parking lot with the minimum. Otherwise, it's a nightmare. That's why most of these fixtures, if they're not open fixtures, they're sits like this and they shoot the lights right underneath and in the front. They're not like open shooting all over. If you Google it, there's a Dark Sky Society of America that people are fighting over turning lights off, and lighting is a whole lot of it turns into politics. Really, there's a Dark Society, I think, Dark Sky Society or something like this. So there's a group of people who are actually pushing legislation so they can turn all these lights off or minimize the amount of lights bill, because we can't see the stars anymore. And yeah, so Google it. It's a whole different area. It's kind of a huggy-feely like Chad, but hey, they have merits though. We want to be able to see the stars, don't we?
Country.
Oh, go to the country. They claim that even in the country right now, with all the light in America all over the cities, you can't. Those guys who like to observe stars, they can't. Yeah, you have to be almost have to be in the North Pole to do that anymore. You're busy watching the chicken of your neighbor here.
Eat it, Don.
Chicken nuggets. After I shot it that one time, it came back.
Any question, guys? The last thing before I let you go eat, there's something called ratio between height to distance. And that ratio, I'm going to give you an example of it. It's in your book. When you put in parking lots, especially in parking lots, how high, Spencer, do I need to put my lighting fixture versus, and how far away from each other I'm going to put them? A ratio, a good ratio, guys, and you can play with it. A good ratio, they call it ratio of distance along to mounting height. It's called the ratio distance along divided by mounting height. Should be able to spell that one, Chad. Okay, distance along to mounting height. Here's my parking lot. And here's my fixture number 1. My fixture number 2. It's the center of the two fixtures. That distance, guys, distance along, this is my distance along. Divide this one by my mounting height. Mounting height, if my fixture, here's my fixture, sitting right in here. This here is mounting height. So the ratio between how far you put them from each other to how high the pole is. Don't quote me on this one. You usually want to contain, you want this ratio to be 2. For example, if the height here is 10 feet, the distance between these two fixtures would give you what? 20. Right? 20 divided by 10, Spencer, is what? 2. If the height of this fixture is 20, the distance between them will be what? 40. Rule of thumb. Really no standards. But the ratio, keep in mind as you lay out your lighting fixture in the parking lot, open area, mostly in open areas, guys, like parking lot and so forth, the ratio you need to kind of shoot for a ratio of 2 to 1. The height versus the mounting, how far away from each other these fixtures will be mounted. Again, rule of thumb, in the software that we use, guys, you're going to have your cutoff isometric curve at 0.5, and you're going to see it. You see that where the curve is, and you're going to grab that, make it overlap. You might end up with 2.5 ratio or 1.5 based on the fixture they use, the height, and a couple of other factors. But if you don't have a software, a rule of thumb of mounting is 2 to 1. I have been told is a good example. 2 to 1. 2 to 1 for the most part, without knowing anything about the fixture and the cutoff and what type of pole and all the stuff. So if you want to throw a number and make the people believe that you're intelligently educated in lighting, and they tell you how do you lay out your lights, just say 2 to 1. So in this case, guys, if this is 20, what do you think the last part here would be to get me a good distribution? This will be 10, and the last part from here to here would be what? 10. That's what a 2-to-1. So you go, if this, typically here's your parking lot, between the two of them is 20. I want to make sure that this is not further than 10 away from the other edge to get me to cover that area. In this case, we are, then if you have the curve of this fixture is going to look something like this. The curve of this fixture is going to look something like this. And all this area is really nicely lit by the parking lot, but not anything else. Not anything else, if that makes sense. So you go from the edge of the parking way, 10, if the mounting is 10, and you put 20. That's a rule of thumb. Brooks, my friend, rule of thumb, it could go more, it could go less. And it depends upon the fixture and aiming and a whole lot of other issues. But that's kind of a good rule of thumb.
Can you give us a formula before that where we were able to tell the distance of the height of each one? Can you just go back one second?
No
Just
problem.
want to write it down. One more.
One more.
Yeah, right there. It's that one in the green.
That one, cosine Q equal the height over the distance.
That's cosine.
Cosine, yeah, Q, believe it or not, it is a cosine.
Q.
Equal Q,
Cosine Q.
yep, cosine Q over equal the height over the distance. And you can use Q as typical term for angle. You can use anything. Cosine the angle, really.
Oh, cosine.
Yeah. When I say Q is a sum, everybody knows that when I say Q is a summation of an angle. Just could be cosine. Could be a cosine ice cream. Cosine the angle. I named the Q. You could name it Chad. You could name it Spencer.
There'll be a lot more answers than that.
So, any question, guys, my friends, about mounting fixtures? In page 47, guys, there's a couple of rule of thumb of how to mount 4-lamper, 4x4, 75. It says indoor situation, approximately one 4-lamp recessed for, giving you an example, 4-lamp recessed 4-foot fluorescent luminaires per 75 square feet will provide 75 mounting foot candle. They're giving you an example. If you don't have a, I'm sorry, I'm looking at page 47, Mr. Erbab, and there's some rule of thumbs. You see rule of thumbs. They're telling you if you use a fixture like this with 4 lamps, and they're not saying anything about the lumens. The lumens probably 3,000 or so, and that one 4-lamper can cover up to 47 square foot. If you are looking for a 75-foot candle. Again, rule of thumb, it really varies. The reason why I don't like it, because in the lighting design now, especially these days, the lamps are different, more efficient, so it might be different than that. But that's kind of a rule of thumb. There's a couple of other rule of thumbs that you guys can look at, but I thought that one in particular stood. The only thing I didn't talk about, guys, is all these formulas, Spencer, are for horizontal foot candles. So if you read the book and say, what the heck, what they mean by horizontal? Horizontal foot candle is right here in front of you. Vertical foot candle is right on your screen. So they can, now what happens if it's a 90-degree angle? Now what if you move that into a different than 90-degree angle? That would be also vertical. So the horizontal is when it's horizontal. Anything that other than horizontal, 90-degree, 120-degree or so forth, that's vertical. Why it's important? Because if you're working on these equipment, guys, not only you need to be able to walk around the equipment, you need to be able to push the buttons and read these stuff. So a lot of applications where you have to do calculation on the wall, not on the floor. They call it vertical foot candle. There's a couple of formulas. I will do it not today. How to calculate it. It's the same formula they use the sign, really. They use this, instead of using the cosine down, the sign will shoot on the wall. The good news is, visual guys can allow you to calculate at any angle. So you can sit, when you choose they call it calculating zone. So where do you want to put your calculating zone? You can put your calculating zone horizontal, or you can grab this wall and make this wall your calculating zone. So you set the calculation zone at this wall. When you run the analysis, it will give you the foot candle at this wall, it default is every 2 feet. Every 2 feet grid. They grid the whole wall 2 feet by 2 feet, and at every intersection of 2 feet by 2 feet, it gives you a calculation vertically. Why it's important, guys? You know, like here, if you're doing schools, why do you think these lights are right here, right above the board? Because you need a light, vertical light, so you can see. Schools, you know, manufacturing places where people have to go read anything on the wall, you have to, the certain factors will require a certain foot candle right on the wall so people can see what they're doing.
Take into account like wall coverings, like
Yes, yes.
reflect-
One thing we didn't talk about, which we will, guys, right here is reflection from the wall. Where we didn't see it much, that's where coefficient of utilization become a big deal. How much of that light that comes out actually is going to reach the floor or the wall versus shoot all over the directions. Or what happened to this light that actually hit the wall right here, bounce off the wall and hit Spencer's face. It contribute to the light, right? So all they call it reflected light. What we've done right now is just the direct light, just from the fixture calculation. Reflected light is much more complicated calculation because not only you have to do a calculation like what we did right at that point, that's coming from every fixture, but you also have to shoot it to the wall. So you need to know the reflection factor of this wall, right? And then see how much of this light is going to reflect and go right at that point. It gets complicated. The nice thing about visual is when you build your room, guys, it asks you about 3 factors: reflection, wall reflection factor, ceiling, and floor. And if you don't know these, there's defaults. So say if you don't know, no problem. Here's a default that we normally use. And it defaults the circuit reflection factor when you do a calculation, especially indoor. Outdoor, we have no walls, right? If you're in parking lot, there's no walls. Unless you want to consider the light coming out of, you know, everything else. But for the most part, it's not an issue outside the reflection from different buildings. Indoor is big deal. So that's what visual
My
thing.
husband did a job where they did a tunnel. They calculated all the light based on a certain type of paint or something, and then they came and they painted it the wrong
Differently.
thing, and it
Was brighter.
really like glossy.
Yeah.
And so when you walked in the tunnel, it was like, you know,
Yeah.
the light was just, so they had to change. it.
Glaring. Yeah, especially somebody driving.
Who
Big
had to
deal.
Fix that, the painter? or
The
something?
painter had to fix
Oh.
it because they didn't put the right covering as they're
Yeah.
supposed to.
Too sheen.
That's part of
Because
coordination.
you walked in and you like literally needed sunglasses almost because they put
Yeah.
the wrong wall covering on.
Yeah.
Wow.
And that's what scares me, guys, when we design system and we add the maintenance factor. If you add a maintenance factor of 80%, this means you will have 20% extra light day one. That might be annoying for some people. 20% extra light than what you designed for day one, because we're going to hope we can count, we want to accommodate the reduction of light in the future. So keep in mind, yes, you can put a maintenance factor of 0.75 just to cover your butt, basically, but be very careful. Day one, your light, day one will be very bright, much brighter than what you thought it would be. So that might annoy some people.
I
So
remember that's where they were burning the twins lights a month or two before this.
Oh.
before they get into
Oh, to
the,
get it down? I was wondering why they had them on every day. Oh,
to get them into the level, acceptable level.
that wasn't just a testing procedure, that was to get them down to par?
I'm sure probably part of it also testing and see how it works. Yeah. Any question, guys? Well, I hope I contribute to your knowledge a little bit today. I'm going to switch, guys, track tomorrow. We still have chapter 5 to cover a few things, but we'll let you go. Okay. And then the rest we're going to do work on Revit today. Power.
Yeah, what chapters can you go over tomorrow? Just 5 or?
Tomorrow, what time? We have homework is tomorrow. Tomorrow. The only thing I need tomorrow for homework, guys, the only thing I need is chapter 1 and the electrical wiring commercial only. And chapter 11 and 12, if I'm in the calculation, only. Everything else will be next week.
What are you going to talk about tomorrow?
I'm going to talk about chapter 2, 3, and 4 in the residential wire, in commercial wire.
Oh, can I want to check my work. I did up to 4 from the 222.
222.
Do you have the answers so I can just kind of check my work?
I will give it to you.
Like, yeah.
We need to scan the other book. We scanned one book, we're gonna put it in there.
No,
we're
You want me to help?
Yeah.
We'll do it. We'll help you.
Yeah, we're gonna scan
Yeah,
it.
you don't have to do everything, you can put some work on it.
That's what I mean, yeah, I'll give it to you just to scan. But, yeah,
Okay,
after
cool.
lunch, do you mind?
Yeah, I don't mind.
We'll get you.
Hey, check this out real quick, Chad.
Let me just, before I check it, can I start downloading? Because last time I did not download and my grandma